Welcome pre-cal students to the homework help video. This is page 544. Number 17 through 29 odd. Please have your books open to that page, have your homework out, have your pencils out, your notebooks out, be ready to take some, or not take some notes, be ready to listen to these explanations. I hope that you've done your homework, you've checked the answers in the back of the book, and now you're watching the video for the ones that you've made mistakes on. The directions say for these problems to simplify the trig identities. Let me go ahead and get this up and running here, and there's the first one. In the blue here is the answer you want to end up with, and the reason I give that to you is I want you to know how far to take this problem. So we are now into simplifying rational trig expressions or trigonometric fraction expressions, and so this is the original problem, and this is the answer you want to end up with right here. So let's go ahead and get started. They have started off, excuse me for a second, they have started off giving you a pretty easy one here. Notice there's not a plus or a minus sign here, so you have one term up top. Notice you do not have a plus or a minus sign here, so you have one term in the denominator also. Whenever you have one term over one term, you're welcome to cancel trig functions out. So here I have sine squared, that's two signs. Here I have one sign, so take away one sign, take away one sign, and you're left with sine x. Here you have two cosines down here, one cosine here, so take one cosine away from both of those, and you're left with a cosine x in the bottom, and of course this is totally gone up here. So what you're left with up top is sine x, and what you're left with in the bottom is cosine x. Now, if you'll look at your basic trig identities I gave you the other day, sine over cosine equals tangent. So that's it. That's a pretty simple problem, and you've taken this rational expression and simplified it down to tangent x. Let's take a look at number 19. Now on this problem here, I'd like to point out to you, you do not have one term in the numerator, and you do not have one term in the denominator. You have three terms in the numerator, 1, 2, 3, and you have two terms in the denominator, 1, 2. So in a situation like this, if you started crossing off signs like that, that would be totally mathematically incorrect. You cannot do that. Now we can maybe factor the top, and that's what we're going to try to do. And I've taught you how to factor these trig expressions. Sine squared x plus 2 sine x plus 1, I would rewrite that as x squared plus 2x plus 1. Okay? Now that's a lot easier to factor. First of all, there's nothing common you can pull out. Second of all, it's a trinomial that has a lead coefficient of 1. Thus, all you have to do is list out the products or the factors of positive 1, and then one of those will add up to a positive 2. Well, obviously, that's going to be a positive 1 and a positive 1, because 1 times 1 is 1, and 1 plus 1 is 2. So the factorization of this trinomial would be x plus 1 in one parentheses, x plus 1 in the other parentheses. Now, when you rewrite that, inserting sine back in, here's what the top, sorry about that again, this computer freezes up sometimes, the numerator would look like this. Instead of putting x plus 1 from right here, you're going to put sine x plus 1, and then for this parentheses you're going to put sine x plus 1. And of course the denominator hasn't changed. That's still sine x plus 1. But notice you can put parentheses around the denominator like this, and now you have a whole group canceling with a whole group, and so you're left with sine x plus 1 all over 1, which is just sine x plus 1. And that's what you're trying to get right here. So again, not too bad. They're starting off kind of easy on you. Let's take a look at number 21. Now on this problem here, notice this is what we're trying to end up with right here. 2 tangent t plus 1 over 3 tangent t plus 1. Now, let's look at the numerator. You have two terms up here, two terms in the denominator. Let's try to factor the top. Now, first of all, pull out what's common. Notice I have a 4 and a 2. Let me put a big long fraction bar here. So I can definitely pull out a 2. Now, also up top, I have a secant in this term right here and a secant in this term. So I know I can pull out a secant t. Now let's see what we're left over with. If I were to put 2 tangent t, let's see if that works. 2 times 2 gives me 4. Secant times tangent is secant tangent, or tangent secant. So we're good. Now over here, I'm just going to put plus 1. And you say, why is that? Well, because 2 secant t, this whole thing, times 1, if you were to go backwards, would give you 2 secant t. So I have pulled out what's common in the top. Now let's go to the denominator. I have a 6 and a 2 at the front of each term, so I know I can pull out a 2. And both of these terms have a secant, so I know I can pull out a secant t. So what we're left over with on the inside would be, let's see, 2 secant t times something has to give me 6 tangent secant. Well, I know I want a 3 here because 2 times 3 is 6. And I know I need a tangent, and I think that's going to do it right there. 2 secant t times 3 tangent t would be 6 secant tangent. And I have 6 secant tangent, or tangent secant, the exact same thing. And then here, 2 secant t, I'm going to put a 1 here. 2 secant t times 1 would give me 2 secant t. So I'm going to put a 1 here. And now look on the outside of your parentheses. You have a 2 secant t and a 2 secant t. Cross that off, and look what you're left with. 2 tangent t plus 1 over 3 tangent t plus 1, which is exactly how far they wanted you to take this problem. All right, moving on to number 23. Now, on number 23, notice we want to end up with 1. Now, it looks like it's going to be difficult to do, but whenever you're trying to simplify these trig expressions or trig rational expressions, just do what you know to do and just kind of watch and see if things don't fall in place. For example, I notice I have 2 terms up top, 2 terms in the bottom. Thus, I'm going to try to factor the top. Now, sine to the 4th power x, cosine to the 4th power x, I would like to pull that off to the side real quick if I could, and just put x to the 4th minus y to the 4th, and x into y. Now, Mr. Earhart, why are you using x and y? Well, I've got a sine and a cosine, so they're 2 different trig expressions. Now, if I were to factor that, I would say to myself, okay, I know the square root of this term, I know the square root of this term, they're being subtracted, so the square root of x to the 4th is x squared, so I will put an x squared here and an x squared here, and the square root of y to the 4th is y squared, so y squared here, y squared here. Make one positive, make one negative. Now please listen, students, let's review. You cannot factor this binomial right here. Do you know why? Just in case you've forgotten, let me remind you. Yes, you know the square root of x squared. And yes, you know the square root of y squared. However, when you know the square root of both terms, this middle sign here has to be negative, or you can't factor it. And that middle sign is not negative. So you cannot factor that any further. However, you can factor this further. We do know the square root of x squared. We do know the square root of y squared. And we do have a negative sign right in the middle. So we can factor that parentheses some more. So I'm going to bring down my x squared plus y squared. And then over here, I'm going to put the square root of x squared is x and x. The square root of y squared is y and y. Make one positive, make one negative. So there, we have factored now completely the entire numerator. So slide it over here. Let's go ahead and put our fraction bar underneath it. And I'm going to go ahead and erase this. Now let's see if we can't factor the denominator. So really I have sine squared x, cosine squared x. I'm going to put x squared minus y squared. And of course, oh, you know what? And I do apologize, students, for making this mistake. I really should fix this right now. Yes, we factored the numerator, but we really have to put our sines and our cosines back in. So x squared would be sine squared x plus y squared would be cosine squared x. We'll have to move that over and get some space here. and then x plus y would be sine x plus cosine x, and then x minus y. I know some of you are thinking, well, Mr. Earhart, it should be sine x. This thing's really acting weird, guys. I apologize. Freezing up. I know a lot of you are thinking it should be sine x minus cosine y because there's a y here. Guys, the x was referring to the sine, the y was referring to the cosine. Thus, that way I knew I had two different trig expressions. So it's sine x, and look in your original problem up here. It was never cosine y. It was sine x, cosine x. So sine x minus cosine x. There. That's what the entire numerator should look like after you insert your sines and cosines back in. So with that in mind, there's the numerator, and let's slide it right over here. And now let's work on factoring the denominator. Now the denominator right here, sine squared minus cosine squared, I'm going to put x squared minus y squared, and then real quick, I'm going to simply put the square root of x squared is x, the square root of y squared is y, make one positive, make one negative, and then there's the factorization of the denominator, except we have to insert our sines and cosines. So now I would have sine x plus cosine x, sine x minus cosine x. Very good. Now, look what cancels. This parentheses here would cancel with this parentheses here. This parentheses would cancel with this parentheses, and you're left with 1 in the denominator. So what you really have then is sine squared plus cosine squared all over 1, or simply anything over 1 is just itself. So sine squared plus cosine squared. Now you might be thinking, well, Mr. Earhart, we're supposed to get 1. We have a long way to go. Well, not really. If you look at your Pythagorean identities we looked at on Friday, your Pythagorean identities, or we looked at the other day, whatever day it might have been, sine squared plus cosine squared does equal 1. So now I can simply put 1 and I'm finished. Okay? That was number 23. Let's take a look at number 25. Okay, students, here is what we were trying to end up with right here. And again, like I've said before, if you can factor, try to factor. In this case here, I have two fractions that are multiplying. So what I'm going to do is I have 5 cosine of this angle right here over sine squared times, now, look at these two terms, sine squared minus sine cosine. I can definitely pull a sine out of there. So if I pull a sine out of both terms, I'm left with, well, I had 2 here, so I'm going to put a sine, and that makes sense. Sine times sine is sine squared, and then minus cosine, because sine times cosine is sine cosine. Now in the bottom, we have sine squared minus cosine squared. I'm going to go ahead and factor that without dropping the sines and cosines. The square root of sine squared would be sine. So we write sine twice. The square root of cosine squared is cosine. So we're going to write cosine twice. And then we make one positive and we make one negative. Now before you do your multiplying, look at all the cross canceling and maybe vertical canceling you can do. See these 2 signs here, sine squared and 1 sine here? I can cross this off and take 1 sine away from here. So now I simply have a sine. See this sine minus cosine right here and this sine minus cosine right here? I'm left with nothing up top here, so that's a 1. I think I'm ready to multiply now. 5 cosine times 1 is 5 cosine. And then sine times, let's see what we have here. Actually, I got to this point here, and if you noticed, I paused the video because I was thinking in my final answer I wanted to have a cosine up top, but it's not. If you'll look closely, it's a cotangent. So I'm going to do something. Remember, you have to be creative, and one of the reasons I give you the answer that you're working towards so you can see what kind of substitutions to make. I don't see a cotangent anywhere. So before I multiply, now again, here's where just practice comes in and years of experience with doing these, but think about this. I don't have a cotangent anywhere in this problem right now, but I do want a cotangent in my final answer. So I'm looking at my basic trig identities, and I notice that somewhere you'll see cotangent equals cosine over sine. You'll see that somewhere on your basic trig sheet. So I have cosine over sine. So see this 5 right here? If I took this original problem right here, and I just put 5 times cosine over sine. I can do that, students. Nothing wrong with that. 5 is really 5 over 1. And if I multiplied it back through, I would get 5 over cosine over sine. So I can definitely do that. I can put a 5 out front here. So if I have 5 times cosine over sine, which I have right here, that's the exact same thing as 5 times cotangent. Do you see that? Because cosine over sine equals cotangent. So I have 5 times cosine over sine, cosine over sine, and cosine over sine is cotangent. So I really have 5 cotangent, or 5 times cotangent. So this whole expression here became this. I put the 5 out front, and this whole expression here became this right here. So now basically what I'm down to is 5 cotangent theta times this fraction up here. So I'm going to grab my handy dandy eraser, and let's see if we can't move this thing up top here. All right, there we go. Now that's a little better. I'm going to go ahead and put it over 1. So 5 cotangent of this angle, whatever that is, times 1 would be 5 cotangent. And then the bottom here, we have 1 times sine cosine. So that would simply be sine plus cosine. And look at that. That's exactly what we wanted to get. So we're doing pretty good. Just 2 down, or just 2 left to go. All right, students, here we go. Now, when you look at this fraction here, if you'll notice, they really want you to subtract 2 fractions. Now, you can't subtract 2 fractions unless you get a common denominator. So I'm going to take this denominator here, and I'm going to factor it real quick, because anytime you can factor, you want to do that. I'm going to use x. I don't like these s's at all. So sine x, the square root of sine squared, would be sine, and the square root of cosine squared would be cosine. So cosine, cosine, make one positive, make one negative, minus, and then this fraction here would be 2 over cosine x minus sine x. Now, please listen carefully, students. I want to help you. Look, we're trying to find a common denominator, and it sure would be a lot easier if I had sine minus cosine, and if I also had sine minus cosine over here. Do you see that? But I don't. I have cosine minus sine. Now, you can change all of the signs in a fraction, or you can change, the signs in the denominator as long as you change all of the signs in the entire fraction. Okay, that's totally legal, okay? So I'm going to go ahead and make this 2 negative. I'm going to make this positive, and actually, it was already positive. I'm going to make this negative, and I'm going to make this positive. So now, having done that, I have negative 2 over sine minus cosine. Now that's going to be a big help later. Now let's find our real big common denominator. Do you remember how to do this? You compare binomials with binomials. So I have one group of sine plus cosine. I have no groups of sine plus cosine over here. So which denominator has the most? This one, and it has 1. So sine x plus cosine x. Sine x plus cosine x. Now, sine minus cosine, there's one group here. Sine minus cosine, there's one group here. Which denominator has the most? Well, they both have 1, so we just need 1. Sine x minus cosine x. Sine x minus cosine x. Very good. There's our common denominator. Now, remember what to do next? We see what do we have extra here that we don't have here, and we write it up here. Well, there's nothing. There's nothing extra we have here that we don't have here, so we simply bring down the numerator, which would be a 1. Now over here, we bring down the numerator, which would be -2, and then we say to ourselves, what do we have extra here that we don't have, or what do we have extra here that we don't have here? Well, a sine plus cosine. So I'm going to go ahead and write up top here, sine plus cosine. There we go. Now I'll probably have to copy this and send it to another page to give us some more room. So we'll do that here in a second. All right, there we go. Now let's go ahead and let's go back a page. Let's glance. Here's what we're trying to get right here in our final answer. So let's see if we can do that. Here we go. First of all, we would have, let's go ahead and simplify the top right here. -2 times sine x would be -2 sine x. And then -2 times cosine would be -2 cosine x. So there, we took that -2 and we multiplied it through. I hope that makes sense. And now we have, now here's where a lot of students make mistakes. They think this minus sign here would just go for the first term. This minus sign goes to the whole top. You're subtracting the whole numerator. So it's 1 minus this whole top. So 1 minus this entire numerator, -2 sine x minus 2 cosine x, all over, of course, your common denominator, CD. So 1 minus this whole thing. Well, this negative sign then outside of the parentheses would change all of your signs on the inside. So it's going to be 1 plus 2 sine x, and then negative times a negative plus 2 cosine x, all over your common denominator. Now let's see how close we are to getting this final answer. Let's go back a page. 1 plus 2 sine x plus 2 cosine x. 1 plus 2 sine x plus 2 cosine x. So our numerator is great. Now the denominator is supposed to be this. Well, students, you're pretty smart and y'all have done well this year. I'm not going to take time and do this, but you realize here's your common denominator right here. Sine plus cosine times sine minus cosine. Would you please trust me, students? And let's not take the time and do this now, but if you were, I was trying to get rid of this here. Obviously, it's not going to work. If you were to take your common denominator right here and multiply it out, sine times sine, sine times negative cosine, and then cosine times sine, and then cosine times negative cosine, you will get this right here. Trust me, you will get sine squared x minus cosine squared x, because what you'll get will be this. You'll get sine squared plus sine cosine minus sine cosine minus cosine squared, and these two terms will cancel out, and you're left with sine squared minus cosine squared. Okay, so if you take your common denominator and multiply those two parentheses together, you will get this right here, which totally means that you've got the exact right answer. You're doing totally well. Okay, so one problem left and we're done with the whole assignment. Let's tackle this last one. Okay, let's tackle this last one. Thankfully, it's multiplication, so we won't have to get a common denominator. Let's go ahead and factor our first numerator right here. Notice I do know the square root of sine squared, and I do know the square root of 9, and they're subtracting. So we can do that pretty quickly. The square root of sine squared is sine. So I'm going to put sine and sine. The square root of 9 is 3, so I'm going to put a 3 and a 3, put a plus, and put a minus. Now let's come down to the denominator. I see absolutely no factoring at all that I can do to that, so I'm just going to leave it alone. Hopefully I'll be okay with that. Now this numerator here, I don't know the square root or the cube root of anything, but I noticed that this term here has a 10 out front and this one has a 5. So I can definitely pull out a 5 because 5 is the largest number that goes into 5 and 10 evenly. So if I pull a 5 out, here I'm left with 2 cosine theta, because 5 times 2 is 10 cosine theta. Then here I'd have a 1 because 5 times 1 would give me a 5 right there. So at least I can pull out what's common up top. And there's really nothing left to factor right here inside the parentheses. All right, let's take a look at the bottom, the denominator here. Notice I have a 3 out front and a 9, so I can pull a 3 out. So if I pull a 3 out, I'm going to put a sine theta right here. 3 times sine theta is 3 sine theta. Here I'm going to put a 3 because 3 times 3 would give me a 9. Now look at all the canceling you can do. This is so cool. I have sine theta plus 3, sine theta plus 3, so I can cancel this out with this. Notice I have a 2 cosine theta plus 1 and a 2 cosine theta plus 1, so I have nothing left here. I'll put a 1. So really what I'm left over with is this parentheses here, sine theta minus 3 times 5. Well, look at your answer. Look what they want up top. Sine theta minus 3 times 5. So for your numerator, I'm going to write 5 parentheses sine theta minus 3. That's exactly what I have. Sine theta minus 3 times 5. And then in the denominator, I have 1 times 3, which is 3, which is exactly what you want. So there you go. You did it. Homework assignment over. I hope you guys will get better and better at these the more you practice. I know they're not easy, and it does just take practice. Call me or email if you have any questions, and continue to work hard.